Hi everyone, welcome back to Coding with Bharat channel. So today let's do the third problem of the recent weekly Leetcode contest, which is count alternating subarrays. So this problem goes like this. It says that let's say you are given a binary array nums. So an array consisting of ones and zeros, and it says that you need to find how many alternating subarrays are there in this nums. So as an example, if I look at this 0 1, then it alternates from 0 to 1. So this is one such subarray. Apart from that, individual single elements can be considered like alternating. So yeah, that is why we have 4 of the single element arrays and 0 1. If I take at a more look at a more interesting case, this, then actually if you look at it, all the 4 elements together form an alternating subarray. Then any subarray of size 3 also, 101 or 010, then any of size 2 also, like 1001 or this 10, or any of them of one size as well. So all the subarrays of this particular array are actually alternating. By alternating we mean we start with 0 or 1 and then have the like different bit next, then the different bit next, and so on and so forth. So yeah, you need to find number of such subarrays which are alternating. So if you think about it, the absolute brute force way of doing this would be to generate all these subarrays and check if they are alternating or not, right? So I'll generate all the 1 length subarrays, 2 length subarrays, 3 length subarrays, and look at each of them if they are alternating or not. So absolute brute force, if I talk about it, any subarray is between an L and R. So what I can do, I can run two loops for L equal to 0 to n minus 1, for R equal to L to n minus 1. So L goes from 0 to n minus 1, R goes after L. So if R is equal to L, that means we have single element. So from there till the end. So now you have LR, which is the one such subarray. Now you need to check if it's alternating or not. So let's say we have answer equal to 0. And what I'll do is I'll say if we check the subarray from L to R, if that is alternating, then we will do our answer plus plus. So, and this check function would simply do start at the first index and check if it is not same as the previous one. So if I talk about the check function, it would essentially look like we have our array, we have L, we have R. I'll start my loop from L plus 1 to R, and I'll say that if array of X is same as the previous one, that means we are already in the wrong territory. Like if two of the elements are same, so it's not alternating, so I'll simply return false. Otherwise, if I complete the loop and every element is alternating, I can simply return true. So yeah, this could be a simple check function pseudocode where we go from L plus 1 to R. For every element we check the previous. If it is same, that means it is false, like it is not alternating. Otherwise it is true. So if you think about the time complexity of doing this, then what we are doing, we are running two loops to fix our LNR. So it is already n square. And in each of those loops, we are doing this check, which is again O of n. So if you think about the total time complexity, it would in fact become n cube, right? We have three loops and it becomes n cube. Okay. Another way in which we can optimize this a little bit is to go for something like a sliding window. So if you think about it, so if you think about it, when we start at some L, right? So let's say our L is 0. So we already know the first element is alternating. Now, if the next element is different from this, then 2 length is also alternating. Then if even the next one is different, then 3 length is alternating, and so on and so forth. So if I think about it, if my L is at this one, then as soon as I reach R equal to 1, it is not alternating. So that means only till 0 it was alternating. But let's say if my L is at this point, right? So 0, 1, 2, 3. So L is at 3. So R equal to 3, it's alternating. R equal to 4 also, it's alternating. 5 also, 6 also, 7 also, 8 also, 9 also. As soon as I reach 10th place is this. I get the first element which is not alternating, and then I have to stop here. So actually, if I think about it, at this particular L, length 1, length 2, length 3, length 4, length 5, everything, till length, I think, what is the maximum length? 1, 2, 3, 4, 5, 6, 7. 7. So till length 7, everything is alternating, right? So basically what I'm saying is, for any given L, for any L where we are at, let's try to find that R which stops being alternating. So what I'll say while, so I'll initialize my R to L, so L plus 1 actually. So while R is less than the size of the array, and till the time this R value is not same as the previous one, we can keep on continuing. So till array of R is not equal to array of R minus 1, you can keep on doing R plus plus. So basically what you are saying is, till the time it is different, right? The next element is different from the previous. You keep on doing R plus plus, and you will stop when two of the elements have same value. So now you have your L. Now you know the R till which we have alternating array. We can know that starting at this L, any subarray till this R will be alternating. So I can do answer directly plus equal to R minus L, right? So yeah, if R just stopped at L plus 1, that means there is only 1. So R minus L will be 1. If R stops somewhere later, then R minus L will give the number of elements in the middle, till which we can stop starting at that L and get a subarray which is alternating, right? So as an example, if I started at this point, then you can in fact see that, okay, till here my R will stop. So if this is the L, let me bold it up. So this is the R. So now, starting at this L, any length subarray, 1 length, 2 length, 3 length, or are alternating till this point, till our R. That is why R minus L gives us the number of alternating subarrays starting at this particular L. Cool. So yeah, that is how you can reduce the time complexity. Now, for every L, you are running one loop to find the R. So the time complexity gets reduced to n square. Okay, cool. If we think one step further, and try to look at how things will happen when L even moves further. So let's say when L moves here. So actually, if you think about it, our R will still stay here itself, right? Because everything in the middle was alternating till this R. So actually, when L moves, R doesn't move. We don't need to recalculate for this new L and go till the end, right? So what if we can in fact do, we can initialize our R to 1 at the beginning itself and remove this from here, and yeah, just continue the R from where we left off earlier, right? Okay. So essentially the point is that if I try to dry run this, when we start with L equal to 0 and R equal to 1, we already stopped, because for R equal to 1, we'll see that, okay, array of R is not same as array of 0. It is not same. So we stop. So for 0, the answer is just R minus L, which is 1 minus 0, which is 1. So answer becomes 1. Next, we move our L here. So as soon as we move our L here and it becomes equal to R, we need to shift our R one step further. So I'll write another if here, that if L has become equal to R, then do R plus plus. So what will happen when L becomes 1, R becomes 2, because L has become equal to R right now and we need to move R one more step further. Okay. So L is here at 1, R is at 2. So again I run this loop. Is 2 same as 1? Answer is no. So we'll do R plus plus. So R actually becomes 3. Reaches here. Now, is array of 3 same as array of 2? Answer is yes, it is same. So we'll have to break from here. So that means starting at L equal to 1, we have two subarrays, 1 and 1, 0. So I'll add 2 to my answer for this second case when L was at 1. Next step, we again move L as at 2. So now R is already at 3, and that is where we have to stop. So sorry, L is here, R is here. So that is where we need to stop because it's automatically same. So again, we'll not run this other loop, we'll not run this if also because L has not yet not reached R. So we'll simply do answer plus equal to R minus L, which is 1. So I'll get plus 1 for starting at this 2. Again, let's move ahead. L at 3, R at 3. But L equal to R, so R moves one more step further. So R becomes 4. So L at 3, R at 4. Now I'll again start running. So R is at 4. 4 same as 3? No. R moves to 5. So R moves to 5. 5 same as 4? No. So R moves to 6. 6 same as 5? No. R moves to 7. So yeah, if you think about it, when L is at 3, 0, 1, 2, 3, R will be at 3, 4, 5, 6, 7, 8, 9, 10. 10 is where we would stop. So we'll add R minus L to the answer. So R minus L, if you think about it, 10 minus 3 is 7. And if you actually look at it, we have 7 subarrays starting here. So length 1, length 2, length 3, length 4, 5, 6, and 7. Length 8 is not possible because it will have not alternating values. Okay. Similarly, when L becomes 4, R can still stay at 10 and we'll add 6 to the answer. Similarly, when L moves to 5 also, R is still within 10. So 5 would be added, plus 4 would be added, plus 3 would be added, plus 2 plus 1. Finally, I'll see L equal to 10 and then R will move further to 11. So if you think about it, what is happening here is for any L, we are maxing out the R, then letting L catch up with this R. Then again maxing out the R, then letting L catch up with this R. So actually, if you think about it in totality, L and R both will move to the end. So the net time complexity of doing all this will reduce down to O of n now, as we are just going to go ahead and do n operations to move to the end. Perfect. So yeah, that is how you can write this particular solution. I had actually written it in a slightly different fashion, but like similar if you think about it. Okay. So what I did was I used a little bit of math to directly get this sum. So if you think about it, this sum 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is in fact sum till 7. So 7 into 8 by 2, which is 7 into 4, 28 directly, right? So what I've done, I calculated how many are together alternating, got that length. Now I know that for first L, I'll get the entire length. For next L, I'll get 1 minus 1. For next, I'll get minus 2. And at the end, I'll get 1. So it's in fact going to be 1 plus 2 plus 3 plus 4 up to length. So that is what I've done. I have added current into current plus 1 by 2 to my answer. As soon as I find, okay, how many are together alternating, and then moved from there to the next path, right? So yeah, a slide more optimization that I've done with the help of maths, but it was not necessary. If you even write this kind of a 2-pointer, it should be good enough. Okay, great then. This was about the third problem. If you liked the explanation, make sure that you hit the like button, subscribe to the channel if you are new here, and let's move on to the last and fourth problem.